getting some stuff down. Stuff that everybody wants on top of their notes, like they don't want to go digging for how to do this shit, right?
What time did we start? Is it 5:10 or 5?
It's 5:10.
Okay.
All right, so we're gonna do the paired samples test today, and if we are quick enough, this goes quick, we will do 11.3, which is the 2 sample test that is unpaired. The idea behind this is, let's say we're talking about stuff that should go together and stuff that shouldn't. Let's say we are looking at comparing the prices of Motel 6 in both San Francisco and Visalia. We have different things based on location. And then what if we looked at Hilton for the same thing, Hilton in San Francisco versus Fresno, something like that. So like Motel 6 versus Hilton, Fresno or Visalia versus San Francisco. Motel 6 is inexpensive. All right, cheap just because it's shorter, but inexpensive is effectively a better word. Hilton is not. Hilton is pricey. San Francisco is pricey too. Everything costs more in San Francisco. Whereas something like in Visalia or Tulare or Fresno locally is cheaper. So I don't really want to compare Motel 6s across cities because they're different prices. If I look at Motel 6 in Tulare, what is it, 50, 60, 70 bucks? If you look at the same thing in San Francisco, it's 150 something, double, just for a different location. So maybe we should look at stuff. Looking at Motel 6 across all regions is not good. In fact, the mean is probably not going to look good for like any of the places. If I have the mean or Motel 6 in Tulare and the Motel 6 in San Francisco, and I find the average price, it's nowhere near the price of either of the locations. So it kind of makes more sense to pair them up by location. Better to pair by location. That's the idea of it. So let's look at some like how we're going to do this with actual stuff. I don't want to use the hotel. It was just the idea. Everyone can gather that Motel 6 is definitely differently priced in the 2 locations, and same with Hilton. Like if you look at Motel 6 in San Francisco and compare it with like the Hampton in Tulare, which is a higher ranking, they're still relatively the same price. At least they were when I wrote my lecture notes. I imagine they're still pretty close. So what do we need to have happen for paired sample tests? Requirements for a paired sample test. Since the stuff is paired, paired up, both sample sizes need to be the same. In fact, that's a helpful thing to know. It's a helpful thing to keep in mind. If N1 does not equal N2, this cannot be the paired test. And since we're pairing up stuff, like if I paired up hotels in San Francisco, like Motel 6 and Hilton in San Francisco, and then I compared them to the Motel 6 and Hilton in Fresno, I can't do that if all the shit's summarized. So, since it's paired, we need the data. So if N1 equals N2, but there's no data table, it can't be the paired test either. Finally, since we are pairing them up, there should be a connection between the two. Something that connects them. In the hotel example, the city that the hotels are in were the connection. This means the samples are dependent. Those are the big things that can help you identify paired sample tests. Something's got to be connected. Now, sometimes the connection is you're looking at a married couple. You're doing one spouse versus the other. Oftentimes, this is when you're using a straight marriage. So you have different genders. Another thing could be you're doing time for the same individual, like a before and after kind of thing. There's some sort of connection between the two. Other than that, the normal rules for means applies. We want sample size to be greater than 30. N1, which equals N2, needs to be greater than 30. Or they need to tell us it's normally distributed. With no outliers. So that's one requirement. Second one is that's general for all means tests. It needs to be a simple random sample. And what that means here is you can't like randomly do like a different husband with a different wife, but you can randomly select couples. Or if you're doing before and after, you can randomly select people. So there still needs to be the connection, but the people that, or the objects you select that are paired up, that's what's randomized. Right here. Huh. Okay. I didn't get MATLAB ready. Fail. Let me get something running. Come on, MATLAB. WTF. It's ready. All right, let's write down the next problem. So you'll see the data set I'm using. Generally, you'll have the data set in the thing and you'll just copy and paste. But so you, for your notes, I will give you a hotel example. So comparing Hampton to La Quinta. Uh, 10 cities were selected. And the box plot shows no outliers. And QQ plot looks good. This is something we did back in chapter 4. This is kind of like how we get normal. The cities are, drum roll please, Dallas, Tampa, Tampa Bay, St. Louis, Seattle, San Diego, Chicago, New Orleans, Phoenix, Atlanta, and Orlando. I'm gonna put lines between every two, that way it's easier to track, see what line, what number's going with what value. Doing every single one just makes the grid too fucking overwhelming. And I'll start filling in the numbers. Bless you. Bless you again. Some places there's not a big difference, like Dallas. But St. Louis, there's a big ass difference. Giving you guys time to write that down. Hampton and La Quinta. Okay, got it all written down? All right, so we're gonna do the hypothesis test. We're going to go with alpha equals 0.05. And we're checking to see, what do we want to check for? That Hamptons are, what do you want to do? Greater than or just not equal to, or? Say greater than, okay. Hampton is greater than La Q. Which means if I want to write that as mu1 minus mu2 is greater than 0, I'm going to have Hampton minus La Q greater than 0. So Hampton needs to be group 1 and La Q needs to be group 2. You guys ready? I have put the data already in here. We are gonna go stats, T-stats, paired. Notice how the other ones have a drop-down menu with data and with summary. Paired, we don't get that option because you can't have a summary. You have to have the data. There is no choice. We said Hampton was group 1. I can manually label them on top so that I could find them easier right here. Notice that it tells us mu D equals mu1 minus mu2. This is what I was saying at the beginning. For some reason, it likes to do that on the paired test. We said we wanted to check greater than. So let's write down what we got. My T-stat is 5.27. I know you can't see what I'm writing, but it's on the screen. My p-value is 0.0003. And I'll come back to the writing. I re-scribbled down what my HA was, because that's what my statement's always about when I do a hypothesis test. I pulled it from over here. Just need to decide if we're supporting it or we're not supporting it. So what do we do with our p-value and our alpha? We compare them. And p-value is less than alpha. The p-val's too low. Reject the hoe. Support HA. Excellent. So we're supporting HA. We're supporting that Hampton Inns cost more than La Quinta. There is sufficient evidence to support the claim that Hampton Inn costs more than La Quinta Inns. Okay. Next example. Roller coaster. So a new loading, unloading procedure was implemented. Process was believed to shorten wait times. Which means you're in line less, you get on a roller coaster faster. Your customers are happy when you're running the theme park. Waiting for fucking 3 hours for Space Mountain sucks. So what the guy does is he takes, he checks before and after implementing wait times. Implementing the procedure, I should say. I hope that's enough. Apparently these are minutes because there's no way that's seconds. You read faster than the rest. Once you guys have it down, we'll reason out what the HA and the H naught have to be. You guys ready? All right. So we need to pick group 1 and group 2, but maybe stopping and thinking about what's going on here can help us. If we think that implementing the new procedure shortens wait times, which group should have the higher average? The before, right? The before should be longer. Before should be bigger than the after. So if we set it like that, we do before minus after for StatCrunch. This is my HA. Which means, and we're talking about the mean. So mu1 minus mu2 is greater than 0. for my HA. And mu1 minus mu2 equals 0 for H naught. But this requires before to be group 1 and after to be group 2. Okay, something else that's handy before I flick over to StatCrunch is when you have shit that's typed up like this and you copy and paste it in StatCrunch, it's gonna land like this. And we like stuff in rows, not columns. So if you have this happen and you're using StatCrunch to switch from this to this, you can do data, arrange, transpose. Highlight the squares you want first. What?
Do you think it's better? You could do it like.
You can't do it the other way.
Oh,
StatCrunch is designed to have the, for a hypothesis says, the shit needs to be in columns. So yes, it's definitely better. And I'll just get ready to, for our next part. Our next part is we know it's a T-stat, I just said that. So I need my T-stat. I need my p-value. And we're gonna use 0.05 for alpha. And I'm going to rewrite down that HA is before is larger than after. Because we're always talking about the alternate hypothesis in our statement. That's the one that matters. I'm freezing and I don't know why. I'm like cold on the inside. That's bad. I was fine today, and I was drinking an iced coffee, and about 2/3 of the way through, I just got chilly and fucking like it feels like it's in my bones and shit, and I ain't warming up. What?
Did I hope you might see?
Oh God, fuck! I hope not. Knock on wood, Jesus! Don't jinx me. Take a look at StatCrunch. I have my data table here. I'll show you doing that. So I have that in there, and I'm going to do data, arrange, transpose. And I got to select the columns that have the data in it that I'm transposing. I don't want to do Hanton La Quinta, that's not part of it, but these are. And what it does is it made new columns. The question is, which one was which? Before was the top one. Oh, look at this. It put 11.6 in the header. So when you do a data transpose, it actually puts the top one up there. So make sure you type it add it back down here. Do that on both of them. The other way you can avoid doing that, oh, let's do that. This is actually better. Put in the labels next to it. Now, actually, I don't even need to highlight those. It's going to tell me which columns to select. Let's delete that column and let's delete this column. I accidentally delete an extra column. No, I got all the columns. All right. By adding in the names, now when I do the data arrange transpose, I can choose that column and it should put it at the top. There we go. What happened? Oh yeah. I got the before and after. Is that the right values? 11.6 was the, yeah, everything's looking right. So that's the pro tip there. Maybe I'll write this on the other thing when I bring the camera back up. And now we're going to do our stats, T-stats paired. We said before was greater than after. That was 1.22, basically. The p-value is 0.1286. Here, and add that note real quick. Make a column with row labels. That helps make sure you don't fuck up and lose some data. And then have a hard time figuring out which columns am I using, because it's all of a sudden there's numbers up in the column names and you're like, I don't what, where's my before and after? So if we label them right away, then it's easy to figure out what goes where. So what do we got going on here? Value is not too low. So we do not reject HO and we do not support HA. So I'm not supporting HA, which means there's not enough evidence to support it. There is insufficient evidence to support the claim. And it wasn't really just before was better than after. The problem was about whether or not the new loading process worked. There's insufficient evidence to support the claim that the new loading process decreased wait times. You want to look at a problem from the homework? All right, let's take a look at problem number 11. The belief that this question is about, when you see it in the homework, it's the belief that sons are taller than the fathers. And there's a data table, which I won't write down because your numbers are going to be different, with sons. It says, what it says is height of father is xi. And height of son is yi. And it tells us, your notes will say the same thing to you when you started, the normal probability plot and box plot look good. So that's what it says, and then I'll flick over to go through the stuff with you. Is ready? The data is in the data table in the blue box. But first it says what conditions must be met to sample, must be met by the sample for this test. Select all that apply. So the differences have to be normally distributed, or the sample size is large. That's one of the things we talked about. Large being greater than 30. Is the sample size large? No, that's not greater than 30. There might be 15 or so there. In fact, it says 13. It should be the father and the son come in a pair. You don't want to like compare, I don't have kids, but if I had a kid and Hansel had a son, comparing my son with him and his son with me doesn't make any fucking sense. We're not related. So we want the samples to be dependent. B says independent sample, which is the opposite of what we want. The 5% thing applies to proportion sampling, and this is not a proportion-based sampling. This is a mean sampling, so they're trying to throw you off with that shit. And the sample size must be large is already listed up there in the normally distributed one. So those should be the two that we're looking for. So I'll write those down. They're probably in a different order for you, but differences are normally distributed. Sample is large. And sampling method must yield dependent samples. Let's check answer. What? What am I missing here? Do you not want me to say dependent sample? Well, that's already in up here.
It's picky though. It like very,
It wants that?
I mean, I don't know, maybe it's both. It's ADD.
Sample size is no more.
That's for proportions.
AC.
Wow, that's some bullshit.
It still was proven.
I guess they want us to include that. That's lame shit. Sample is less than 5% of the population. So it says let D1 equal X1 minus Y1. X1 is fathers and Y1 is sons. So this says fathers minus sons. Fathers minus, if the sons are taller than the fathers, then the sons should have a bigger number than the fathers, right? So Y should be bigger than X. Which means I should end up with a negative number. This is always equal 0. This is less than 0. Now, before I'll come over to the camera and walk through the talking of it. It says that sons are taller than fathers. But this is my Y group and this is my X group. So if I switch it around, I got to put X first because that's how they had it. The alligator has to keep chasing the Y, which means it's going to put it over there. So I'm doing the XI minus YI is less than 0. I'm picking the less than. Okay, back to the problem. We'll click check answer. Calculate the test statistic means I should load this in StatCrunch. I don't need to do the highlight and copy. I can just do this little blue box here and say open in StatCrunch. And I am doing father less than son. So I got stats, T stats paired. The height of the father is less than the height of the son. And they gave us some stuff. They give us the T stat, which is what was asked for. They asked for the test statistic. Hang it all down right now, just so I have it. P value is 0.5038. You can't get more meh than that. Like if the P value is 1, it's clearly the other way around. If the P value is around 0.5, it's like they're about the same height. So let's come over here and type in what I had. Round to 2 decimal places. I had 0.01. My p-value to 3 decimal places was 0.504. Should the null hypothesis be rejected? The p-val is not too low, so we do not reject the HO. HO is the null hypothesis. So I'm going to put not too low. Do not reject H naught, do not support HA. Let's see what the drop-down menus ask for me to do here to get that. Do not reject H naught because the p-value is larger. Since we're not rejecting H naught, we're not supporting HA, which means there is not sufficient evidence to conclude that sons are taller than their fathers. That's it. So that's why I put the note in here. That one had some tricky shit at the beginning. It's gonna piss you off because it pissed me off.
Every time. Like, oh my God, I'm gonna throw my computer.
StatCrunch will piss you off, and guess what? That's why your final doesn't have StatCrunch on it. I'm doing all the StatCrunch work for you on your final. It shouldn't be about navigating a fucking computer program. It should be about understanding the basics of statistics.
I wanted to, I just shut my computer instead of like raging and throwing it.
Let me show you guys something. You'll like this. This is great. Great. I still need that computer. Need it over here. Look at like the proportion stat ones. This is the fucking kind of formula and shit they would do by hand. Right?
Yeah.
StatCrunch isn't looking too bad now, is it?
So it helps a lot.
Find the Z stat. That one's ugly too. You need the p hat, x1 plus x2 over n1 plus n2. Doing this by hand sucks. There are teachers here that still do it.
You have Mag Math Club, there's people in there, their teachers don't let them, it's like, hey, do it.
Yeah, I'm like,
Like, man, that sucks for you.
what it is they had to learn it by hand, and it's fucking like you're gonna do it that way too. And I had that mentality for all about 1 year, and I thought, who the fuck is gonna pay an employee to do this shit by hand when you know even the smartest of employees are gonna make a mistake? All it takes is just hitting the calculator too fast or typo, transposing numbers when you type them in, everything's wrong. Yeah, you're doing a table, you gotta make a bunch of stuff here. Too many ways to make errors. No employer, when you're doing this in real life, is gonna have you do it by hand. They're gonna have you doing it with statistical software. There's R, there's StatCrunch, there's something with a PSS, IPSS, something. I don't know.
What's Desmos?
Desmos is an online graphing calculator.
Oh. Separate that.
Desmos, you can do some stats with it. It is not ideal.
This is on the-
For stats, it sucks. Does it? I don't know, we'll get all the way through 11.3, and if we do, it's gonna run all the way to 7, and we can do it another time. Especially with me having the chills right now. If I didn't have the chills, I would make you grind through it. Any questions?
Something guilty conscience, that's about it.
Guilty conscious about what?
Eat shit or something.
No. I got no guilt about nothing.
You're like, yeah, no.
I even got a call from my dean today. Saying, I know you probably didn't mean it this way, but a student had their feelings hurt. No, it was, I get why. The STEM students, they had a contest on Friday night. And one of the smartest students on campus didn't participate. He was there, he was in the room next door working on his homework and stuff, and he didn't do it. It was a former student of mine. And so I heckled him. And then I heckled him on Discord. And apparently he like was embarrassed by the spotlight of it. And so like, I don't know if the dean just overheard students talking about it or if the student said something. But the dean said, you know, you're in a position of power. You can't be too mean to students. You can't hurt their feelings. I'm like, he's trolled me in class before. I thought it was all good. It was a more of a, he could do it, but not take it, which is some bullshit.
Yeah.
If you're gonna throw shade at the teacher, you better be ready to take it back. But it happens, and so I apologized to him and it was all good. You know, I don't think he actually said anything to the dean. I think that students were going, damn, did you see him Jones just fucking throwing some heat, annihilate him? And they coming back, the dean like walks through the area where the STEM students are studying and just overheard it and thought he better say something. I don't know if that's what happened. But the student was fine, I emailed him, or, you know, message him and talk to him, he's all good. All right, go home, get the fuck out. I know some of you are waiting for that. Ooh. Give me a second. Guess I'll just hit end.